Okay, so now we start our trig. We did a little bit in that extra credit. That was before spring break. When we're dealing with right triangles, you can use your trig function, sine, cosine, tangent. There's actually three more, but we're not going to do those in Math 3. But they're secant, cosecant, and cotangent. But we're only dealing with sine, cosine, and tangent. Okay? You have to memorize. Now, you may have learned SOHCAHTOA. I never learned it that way. I just learned sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Okay? You have to memorize that. Number one. Number two, you have to be able to know what is opposite and what is adjacent. Opposite means directly across from the angle, the side across from the angle. So, this is called theta. Theta is a Greek symbol used to represent any angle. Okay, we don't know what that angle is. It's like x. Okay, we just call it theta. But the side opposite this angle right here is this side. That's across. That's the side opposite. Okay? Adjacent is the one right next to it. Hypotenuse is always directly across from the right angle. That's always a hypotenuse. So you have to be able to recognize what's opposite, what's adjacent, and what's the hypotenuse. Now, when I say sine of an angle, if I know what that angle is, say that angle is 60 degrees, sine of 60 degrees is a numerical value. That's an actual calculation. In your calculator, you have a sine button. So if you do sine 60, it'll give you a number. Okay? So, in a sense, these are proportions. Sine of an angle equals whatever the length of the opposite side divided by the length of the hypotenuse. Okay? You could put all of these and write them as a proportion. If you put that over 1, you cross multiply to solve. Okay? Because if I know what this angle is, say that's 25, sine of 25 degrees, that's just a number. Okay? In a lot of cases, you'll be missing one of those, so you'll call it x. So you'll cross multiply to solve for that. Okay? However, what we're going to do today also is, what if we don't know the angle? What if we know the length of all the sides and we need to figure out the angle? We're going to figure out how to do that also. Okay? Any questions so far? Okay. So here's example 1. Now, in your homework, it's going to say find all 6 trig functions. But I specify I only want you to do sine, cosine, and tangent. Okay? It says evaluate the sine, cosine, and tangent of the angle theta shown in the right triangle. Now, we're not finding the angle. All we're doing is writing the sine, cosine, and tangent ratio of that generic angle. That's all we're doing. Okay? Well, in order to be able to do sine, cosine, and tangent, you need a value for all 3 sides. You can't have a side missing and the angle missing. Okay? You can't do anything with that. That's too many unknowns. Okay? But we can figure out the measure of that third side, huh? Pythagorean theorem, right? Pythagorean theorem. So, my hypotenuse is what we're missing, correct? In reference to this angle, what is 4? Opposite, correct? That's opposite. And what is 3? Adjacent. Okay? Hypotenuse is what we're missing. Okay? So you do Pythagorean theorem real quick, and you do 3 squared plus 4 squared equals c squared. So you end up with 25 equals c squared. What do you do next? Take the square root of both sides, and you get c is 5. So my hypotenuse is 5. Okay, we should have recognized that. If your legs are 3 and 4, your hypotenuse is 5. That's a special kind of right triangle. 3, 4, 5. Okay? Now, after you have a value for all three sides, then you can go and tell me, what is the sine ratio, what is the cosine ratio, and what is the tangent ratio? When you have to be careful with these is when you find that missing side, you're gonna have to use Pythagorean theorem to do that. When you find that missing third side, when you take the square root, if it is not if it's not a whole number, then you leave it in square root form. You do not want to round off. You leave it in simplest radical form. So whatever the square root is, you have to simplify that. Okay? You also need to remember that when we write these ratios, opposite over hypotenuse or adjacent over hypotenuse, your denominator cannot have a square root in it. So if you have a square root in the denominator, you have to fix it. You have to rationalize it. Okay, we did that. So this one, they're all whole numbers, 3, 4, and 5. So it's not that difficult. So when we do, so I say sine of theta equals opposite over hypotenuse. And now we go put in those values. We don't know what theta is. It's going to stay theta because we don't know what the angle is. So what is opposite? 4, and hypotenuse is 5. That is what sine of theta is equal to, 4 over 5. When you get a fraction, you want to make sure that it's reduced if it needs to be reduced. So you want your answer to be the simplest form, but it needs to be exact form. So you're not going to actually divide and round off and things like that. Okay? So now we'll do cosine. Cosine of theta is adjacent over hypotenuse. What's adjacent? 3, and hypotenuse is, so 3/5. Cosine of theta is 3/5. It just wants that ratio simplified. Tangent theta is opposite over adjacent. Opposite is 4, and adjacent is 3. So just leave it. Don't change it to a mixed number. Just leave it 4/3. As long as it can't be reduced, just leave it alone. So if it just tells you to evaluate the sine, cosine, and tangent, that's all it wants you to do. Okay? You have to read these directions for each set of problems carefully, because sometimes it wants you to find the angle. Sometimes it just wants you to find the missing side. Sometimes it wants to evaluate the function. So you have to be careful and read the directions and do what it's asking you to do so that you don't do more work than necessary. Okay? So I want you to try this one. So you'll have 5 squared plus 10 squared equals c squared. So that ends up being 125 equals c squared. So you'll take the square root. So the square root of 125, that's 25 times 5. So it's 5 square roots of 5. Okay, so here's your angle. What's 5? Opposite. What's 10? Adjacent. And this is hypotenuse. Okay? So sine of theta is opposite over hypotenuse, which is 5 over 5 square roots of 5. What happens to these 5s? They cancel, right? So that just leaves me 1 over the square root of 5, but I can't leave it like that. So how do I get rid of square root of 5? Multiply by square root of 5. What happens when I take square root of 5 and multiply it by the square root of 5? I just get 5. So we multiply this by the square root of 5, and that'll give me 5 on the bottom, but if I do it on the bottom, I also have to do it on the top. So that just gives me the square root of 5 over 5. So you'll do cosine the same way. Okay, let's see how cosine went. So cosine of theta is adjacent over hypotenuse, which is 10 over 5 squared root of 5. And I can reduce 10 and 5, right? Okay. Any chance you get to simplify it, you want to go ahead and do that. So that'll leave me with what on top? 2, right? So now we have just 2 over the square root of 5, which is good. It's simplified, it's just not fixed. It's unstable. Can't have a square root in the denominator. So we multiply by the square root of 5 and the square root of 5. And we get 2 square roots of 5 over 5. So tangent of theta is opposite over adjacent, which is 5 over 10, which reduces to 1/2. 30 degrees, 45 degrees, and 60 degrees. Those are the special angles. When we start the next chapter, we're going to start talking about the unit circle. The unit circle, every single angle in the unit circle deals with these 30, 45, and 60 degree angles in the unit circle. Okay? Those, if you know the ratios for the right triangles, for those special right triangles, those are pretty easy to do. Now, these triangles won't be drawn for you. If it asks you what is sine of 30 degrees, you should know that's part of a special right triangle. Let me draw that right triangle. Let me draw in those ratios that I know, and then let me fill that in. Okay? Because in your calculator, if you do sine of 30 degrees, it's going to give you a decimal answer. Now, if the instructions say round your answer to the nearest hundredth or tenth or 10,000th or something like that, absolutely use your calculator. You wouldn't go through all this trouble manually if you didn't have to. But if it wants an exact answer, this is the only way to do it. Because your calculator is not going to tell you it's square root of 3 over 2. Okay? You have to do it like this. You can only do it this way if it's 30, 45, or 60 degrees. You can only do it this way if it's those. Because those are the only pieces of a special right triangle. Those are the only ratios of those sides that we know automatically. Okay? And so let's look at the first one. Okay, 30 degrees. So if here's my angle, I'm going to say this is 30. I mean, here's my triangle. We'll say this is 30, which makes this one 60. Okay. So just like we did over here, let's put those ratios. 30, 60, 90. That's 1, 2, square root of 30, correct? Where does the 1 go? Across from the 30. Where's the 2 go? Hypotenuse. And the square root of 3 goes? Across from the 60. Okay? Now, in what we did before, we just said, we gave you a triangle, and we just called one of those angles theta, and I said, now tell me the ratio of the sine of theta. Okay? The only difference between that and this is that we actually know what that angle is. But that doesn't change our answer. We're still writing the ratio of that. So we're saying sine of 30 degrees. Whatever that ratio is going to go here. You understand? So, sine of 30 degrees is, again, what's sine? What over what? Opposite over hypotenuse. So opposite over hypotenuse. So here's our angle we're talking about. What's opposite? 1. This is opposite. 1. And the hypotenuse is 2. So 1/2. So sine of 30 degrees is equal to 1/2. And if you actually go and calculate that in your calculator, you'll do sine of 30 degrees equals, and it'll say 0.5. Now, what do we have to do? Anytime you hit sine, cosine, or tangent in your calculator, you have to make sure, what? That it's in the correct mode. Now, in this section, we're only working with degrees. But tomorrow, we start working with radians. So you're going to have to go back and forth between degrees and radians based on what the problem is. If it says, find the angle to the nearest degree, when you hit that sine button, your calculator has to be in degree mode. Okay? And so, if you wanted to just check this, you could say sine of 30 degrees, and it should tell you 0.5. If it doesn't, calculator's in the wrong mode. Does everybody know how to check the mode in their calculator? Yes. Okay? Right next to the second button, it says mode. If you hit mode, you want to go down, and you want to make sure that degree is in bold. If you reset your calculator, it's going to automatically make radian the mode. Okay, so you want to make sure that it's correct. Okay, so now let's do cosine of 30 degrees. Cosine is what over what? Adjacent over hypotenuse. Adjacent over hypotenuse. Adjacent is what? Square root of 3. And hypotenuse is 2. I'm all right with that. The only problem comes in is when you have a square root in the denominator. You have all the square roots you want in the numerator in the top. You just can't have them on the bottom. Now, tangent. Tangent is what over what? Good. Opposite over adjacent. What's opposite? 1. And what's adjacent? So, is that okay? No. So, what do I have to do? Good. Multiply by the square root of 3. So, my simplified answer is the square root of 3 over 3. So you have to do that for 45 degrees and 60 degrees. Well, if it were me right now, I'd just go ahead, since I already have the 30, 60, 90 one done, I'd do the 60 degrees. Okay? So y'all go ahead right now and do sine of 60 degrees, cosine of 60 degrees, and tangent of 60 degrees. The hypotenuse always stays the same. But now, whereas when we were dealing with 30 degrees, this was the adjacent. When we're dealing with 60 degrees, this is the opposite. And this is the adjacent. Okay? The hypotenuse never changes. It's always across from the right angle. So those values are in respect to the angle that you're looking at. Opposite changes if you change the angle. You understand? Find the exact value of x and y. Now, if it didn't want the exact value, if it wanted a rounded off value, then we could use our calculator to do that, because we could calculate, say, the sine of 60 degrees or the cosine of 60 degrees. But since it wants an exact value, we have to put in exactly what that is, exactly what the sine of 60 degrees or the cosine of 60 degrees. We can't just put the ratio because we're missing 2 out of the 3 sides. So Pythagorean theorem is not going to help us until we know at least one of those other values. Right? Once we know either x or y, we can use Pythagorean theorem to find the other. Okay? But we have to use trig when we can't use Pythagorean theorem. Okay? So 60 degrees is our theta, it's our angle. So if I wanted to find x, this is what you have to ask yourself. What are these in reference to 60 degrees? Well, what's 10? 10 is the what? Okay, so hypotenuse. That one's the easiest one to identify. What is x? It's across from it, so it's the opposite. And what is y? Adjacent, okay? So now you're going to ask yourself, so let's see if we can figure out what x is. X is opposite. So we're looking at opposite and hypotenuse. You want to use the value that they give you. So which trig function uses opposite and hypotenuse? Sine. Sine uses opposite and hypotenuse, right? So we know this. We know that sine of theta equals opposite over hypotenuse. Okay? Well, we know what theta is. We're going to fill that in. That's 60 degrees. Sine of 60 degrees equals, the opposite is x, and hypotenuse is 10. So now look at your chart and tell me what is the exact value of sine of 60 degrees? Square root of 3 over 2, right? Okay, square root of 3 over 2. So the square root of 3 over 2 equals x over 10. What do you think we do now? Cross multiply. We cross multiply to solve for x. So 2x equals, is that the square root of 30? No, Dyer, we can't multiply 3 times 10 because the 3 is underneath the radical and the 10 is not. So that's just 10 square root of 3. Now we do what? Divide both sides by 2. What can I do with the 10 and the 2? I can simplify that because they're both outside. They're both outside the radical. So 10 divided by 2 is 5, so it's 5 square roots of 3. Okay? I want you to find y using the same method, not Pythagorean theorem. All right, so in reference to 60 degrees, we have adjacent, and we want to use what they give us. So that's cosine. So cosine of theta is adjacent over hypotenuse. So cosine of 60 degrees is y over 10. Cosine of 60 degrees is what? 1/2 equals y over 10. So we cross multiply, 2y equals 10. Divide by 2, and y equals 5. Okay? And you could have used Pythagorean theorem to find that, because it ends up being a whole number. It's not something you have to round off. Sometimes when you have a bunch of different things that have radicals in it, Pythagorean theorem gets a little bit messy and increases your chances of making a mistake. Okay? Any questions? The next set of problems, it asks in your homework, it asks you to solve the triangle. Solve the triangle means it wants to know what are all the angles and what are all the sides. So they give you some things, but they don't give you everything. So you have to figure out the rest. So it says solve triangle ABC. So solve means it wants all of the missing values, all of the missing angles, and all of the missing sides. Well, they gave us 2 out of 3 angles. What do you have to do to find the third angle? Yeah, add them up and subtract from 180. Now, is that a special right triangle? No, it is not a special right triangle. So we cannot we cannot find exact values for those missing sides. It's not possible. Okay? And so we're going to be able to use our calculator to work this. Okay? So first thing you want to do, if it says solve, then you want to know angle A equals what? Angle B equals what? And angle C equals what? Side A is what? Side B is, and side C is. That's what the answer is going to be all three of those things. I mean all six of those things. Some of that they gave to you. Okay? What's angle A? They gave us that. What's angle C? They gave us that too. So to find angle B, add those up and subtract from 180. Which is 71 degrees. Okay? Finding the missing angles easy. That doesn't have anything to do with trig. If you have 2 out of the 3. Okay? Now, we don't know what side A is, but they gave us side B is 13. So I'm going to fill that in. So all we need to do is go figure out what side A and side C is. Okay? Again, I don't want to use a value that I found in case I got it wrong. So I want to use the value that they gave me. That angle that they gave me, 19 degrees. So that's my theta. That's the angle that I'm talking about. Everything else is going to be in reference to 19 degrees. So what is A in reference to 19 degrees? Opposite. What is B? And what is C? Okay? So if we're going to solve for A, what value am I going to use? What trig value? Tangent. Opposite over, we have to use adjacent. That's what they gave us. So opposite is what we're trying to find. Adjacent is what they gave us. So that's tangent. So we say tangent what? 19 degrees. Tangent 19 degrees equals opposite over adjacent. So A over what? 13. Tangent 19 degrees is a calculation. Okay? I'm not going to calculate it just yet. We're going to put that over 1 so that we have a proportion. Okay? Now we're going to cross multiply. A times 1. So A equals 13 times tangent 19 degrees. You don't want to round off and then use a rounded off value in your next calculation. Okay? So you just want to do one calculation and round off at the very end. So now you guys tell me, I want you to round it to the nearest 10. Your calculator needs to be in degree mode. If it's not, you're going to get it wrong. So 13 times tangent 19 degrees is what? 4.5. So side A is 4.5. Okay, if you trust that answer really good, you could use Pythagorean theorem now to find that missing side, to find C. And that's okay. If that's what you want to do, that's up to you. Just to practice our trig a little bit more, I'm going to go ahead and use trig to figure out what side C is, what the hypotenuse is. So again, I'm going to use the side that they gave us, which is the adjacent, and we're trying to find the hypotenuse. So which trig value is adjacent, has adjacent and hypotenuse? Cosine. So we will say cosine of 19 degrees is adjacent, which is 13, over hypotenuse, which is C. So put it over 1 so that we have a proportion. Now when we cross multiply, what's going to end up happening, it'll be 2 steps. Okay? So it'll be 13 equals C times cosine of 19 degrees. Then you'll have to divide both sides by cosine of 19 degrees. Cosine of 19 degrees is just a number, it's just a calculation. Okay? In Math 2, we learned some rules for proportions. Okay? That makes this calculation a lot easier. What you can do, anytime you have a proportion, everybody eyes up here. Anytime you have a proportion, you can switch these two, and that proportion, the value of that proportion stays the same. You can reverse these two, and the value of that proportion stays the same. So, this is, if I switch these two, C equals 13 divided by cosine of 19 degrees. You can cross multiply, and you'll just do two steps to get you to that same point. So save yourself some time. See, we didn't do that here because our variable was at the top. See what I'm saying? We did that here because our variable was at the bottom. So the rules for proportions say, one of the theorems says you can do that. It's legal. So now you just do 13 divided by cosine of 19 degrees. Round it to the nearest 10. What'd you get? 13.7. So now we have solved that triangle. We have all the angles and we have all the sides. The last set of problems has to do with figuring out what the angle is. So they give us the lengths of the sides, but they don't tell us any of the, we only know the 90-degree angle. So you have to figure out what is theta. Okay? So that is what I'm talking about, although we'll use the inverse trig functions, okay? Like when we're trying to solve for x, if it was x plus 5 equals something, we do the inverse operation. If it was plus 5, we would subtract 5, right? If it was times 5, we would divide by 5. We do the inverse operation, correct? When you're trying to find the angle, you do the inverse operation, okay? So that's when you do second sine, okay? You plug in that ratio. The ratio is what goes here. When you hit enter, that answer will be your angle. So let's just do that straightforward by hand. We don't have the triangle or anything like that yet, okay? Okay, so that's 60 degrees. If you didn't get 60, then your calculator's not in the correct mode. Yes, you do sine, you hit second sine, that'll give you the inverse sine. It's going to automatically open the parentheses for you. So you have to put square root of 3 over 2, and then close the parentheses and hit enter. Okay? Any questions? So now they give us a triangle. And they tell us, find the measure of angle theta. Now, we're going to round this to the nearest whole degree. So you have to figure out the sides that they gave you. What are they in reference to your angle? What's opposite? What's adjacent? What's hypotenuse? Okay? Here they only gave us 2 out of 3 sides. Sometimes they give you all 3 sides. If they give you all 3 sides, then you have your option of which trig function you want to use. Okay? Here I don't have an option because they only gave me 2 sides. Which 2 sides did they give me? Adjacent and hypotenuse. This is adjacent and this is hypotenuse. Which function is that? Okay, so we say cosine theta equals adjacent over hypotenuse. We don't know what theta is. That's what we're trying to find. Cosine of theta equals adjacent, which is 5, over hypotenuse, which is 9. Now, we have to figure out what theta is. Cross multiplying is not going to help me. The only way to separate this from this is to do the inverse trig function. So we'll say this, theta equals cosine, the inverse cosine of 5/9. Because remember, it's the inverse cosine of the ratio equals the angle. So you just calculate that. Round it to the nearest whole degree. Okay, here's your homework.